This is the continued video of the previous one on inequalities domain. Oh wow, now we are given two different inequalities, two separate inequalities. Okay, the first inequality doesn't look bad. Like x is smaller than or equal to 3, that's fine. But the second inequality, we have a negative sign here. So we'll have to flip the sign, and when we flip the sign, you know what happens. So let's see, x is greater now than minus 5. We should also flip the sign of minus 5, right? And the symbol now turns to opening its mouth to x. Make sense? Okay, so now we're gonna show this graphically first before writing down domain. And you'll see why. So we're trying to show this graphically to satisfy both equations at the same time. So let's draw the first one. X is smaller than or equal to 3. So we have to color the dot at 3, and then x is smaller than, so we have to make it go to the left. So I just showed graphically for the first inequality. So I'm gonna color this box. And now let's look at our second inequality. I'll use a different color. X is greater than minus 5. So we should start from minus 5 but exclude minus 5 because we should not include minus 5, right? And x is greater, so it has to go this way. Okay, this doesn't look clear. I should have maybe drawn the orange line longer. I'll do that now. So draw it longer, further. Okay, maybe I should. Oh, okay. I'll just draw it again. Yeah, okay. That looks more clear now. So the second inequality is shown with green color. So I'll put a box here as well. In order to satisfy both inequalities at the same time, our x value should be somewhere in this region. So I'll color it with red. So this region is where both inequalities will make sense for our x value. Imagine if our x value was outside the red region, for example, x being equal to 4. Then x is greater than minus 5, so that makes sense for x being 4. But x is smaller than 3, that doesn't make sense because our x value is 4. We cannot satisfy both inequalities at the same time unless we're in this region. And of course, that region should not include minus 5, okay? Make sure of that. So let's write down the domain. There we go. By this point, please make sure that you're following me well. It's very important that you understand this. So we have x is greater than minus 5 and smaller than or equal to 3, which corresponds to this red region. This is a combination of these two inequalities, okay? So being greater than minus 5 satisfies this green inequality, and smaller than or equal to 3 should satisfy the orange inequality. We have a domain that can satisfy both inequalities at the same time. You may also pause the video for a moment and make sure you're understanding this. Once again, the question asks for x that can make sense with both inequalities at the same time. And we have a domain for that. Let's move on to the next question, shall we? Question 7. Now, there are up till 10 questions for you to fully understand grade 8 inequalities. So let's continue a little more. We have two inequalities again. So our first inequality seems okay again, t is greater than 3. But the second inequality seems we need to tweak it a little bit. There's 1 over 2 in front of t, so we have to multiply both sides by 2, right? T is gonna be smaller than negative 2. Now everything looks better. Just as on the previous question, let's first show them graphically. I'll use the orange color for the first inequality again. So t is greater than or equal to 3, so I should color this 3, and we should go toward right. Now using the green color for the second inequality, t is smaller than minus 2. Smaller. Okay, so we should exclude, we should not include minus 2 because there's no equal sign, and it should go toward left. Make sense? Oh look, there are no overlaps. We don't have any overlapping region. So that means we can never satisfy both inequalities at the same time. For example, if our t value was negative 4, that may satisfy the second inequality because t should be smaller than minus 2, and that makes sense. But if our t is negative 4, then it cannot satisfy the first inequality, right? So we can never satisfy both inequalities at the same time using one value of t. In this case, we say that there are no solutions for this question. By the way, there could be another type of question, which may be asking to find a domain that doesn't need to satisfy both inequalities at the same time, but just satisfies one of the inequalities at a time. So, this or this. In that case, we can have a domain as the following. So, again, if the question is asking us to satisfy both inequalities at the same time, then we won't have any solutions for that. But if the question is asking for either this or this, then we could simply include the word or in between the two information like this. By the way, someone could be asking me this. Can't I just combine these two inequalities like this and then write it down? T is greater than or equal to 3, which is from here. And t is smaller than negative 2, which is right here. So doesn't it make sense? What do you think? Do you think I can write it like this? The answer is, of course, no. This is like we're saying that negative 2 is the largest number in here. So we're meaning that negative 2 is greater than t, but even greater than 3. And is negative 2 greater than 3? No, that's not possible, right? So we must write them separately, unfortunately. So this one is wrong. We should be writing in this way, never in this way. Alright, let's continue. We have again two inequalities. The first one seems okay. A is smaller than 3. That looks good. The second one, I guess we'll have to change a bit. We should move the plus 1 first, right? So if we move plus 1 to the other side, it's going to be 1 over 2a is smaller than minus 1. And then we'll have to multiply both sides by 2, right? So a is going to be smaller than minus 2. So now we are all good. We have two good inequalities. Now let's do the graphing. Again, I'm going to use the orange color. A is smaller than 3, so draw a circle, empty circle on 3, then go this way. Actually, I should draw it longer. Okay, that looks better. And now using the green color, A is smaller than negative 2, so draw an empty circle at negative 2, smaller, so also this way, smaller. Oh, look at this. They're both heading toward left. So this means our A value can satisfy both inequalities at the same time if the A value is less than 2. That's where these two lines are overlapping, right? So pretty much this orange line is useless in this case. Yeah, that can happen. So now let's write the domain. So we're going to introduce A, put a wall. A is smaller than negative 2, and that's it. We shouldn't even be mentioning A is smaller than 3. Okay, two more questions left. So the first inequality looks okay as usual. The second one, okay, there are a lot to change. Let's first move 1 over 2 to the other side, right? So it's gonna be minus 1 over 2, because plus 1 over 2 on the other side is gonna be minus 1 over 2. And then we'll have to flip both sides, right? And when we flip it, what did I say? We have to flip the symbol as well. And it's going to be minus 2. The minus sign will still be there, because whether it's in the numerator or denominator, it doesn't matter, right? But the 2 matters. So we're just flipping 2. Now let's show it graphically. Again, orange line for the first inequality. Greater than minus 3, so it should go this way. So this region. The green line, x is greater than negative 2, so it's gonna also head this way. So this looks like x being greater than minus 2 will satisfy both inequalities at the same time. Like this region will only satisfy the first inequality but not the second one, right? So if we write the domain for this, like in the previous question, we're only gonna need our second inequality to satisfy both inequalities at the same time. Are we clear? Finally, last question, yay! It seems like we'll have to change both inequalities here. They both look messy. So let's change the first one, make it look nicer. So we have to move +4 to the other side. So it's gonna be -6, right? And then we're gonna have x is greater than or equal to -3 because we're dividing both sides by 2, right? So x is this. Now second inequality. Let's flip the sign first. So 1 over x is greater than 2 because we are flipping the symbol as well. Then we're gonna flip the fraction. So x is gonna be, we're flipping this one too, so 1 over 2. And we're flipping the symbol as well, right? Oh, actually it came back to the original symbol. That can happen. Okay, so we can now use these two. The first one, x is greater than or equal to -3. So there's an equal sign. So this time we're gonna color the dot. X is greater than or equal to -3. So we have to make it go this way. Now the next one. X is smaller than 1 over 2. Smaller than 1 over 2. That should be somewhere in here. But without coloring it because it's not including 1 over 2, right? And x is smaller, so we should go this way. Now we see that only this region will satisfy both inequalities at the same time. Make sense? So writing the domain. X is greater than or equal to -3, so starting from here. And x is smaller than 1 over 2, ending in here. So this domain represents that region. So x is in between -3 and 1 over 2, and x is in between -3 and 1 over 2. And of course, we should exclude 1 over 2. Okay, now we're done. We have just covered 10 questions to learn inequalities. Thank you for watching, and I'll see you next time.